welcome to my YouTube channel. In this video, I'm going to explain you how to draw diode clipper circuits. Yes, there are many types of diode clipper circuits according to the placement of diode in the circuit, like series diode clipper, shunt diode clipper, and also depending upon the waveform, that is output waveform. It's like positive peak clipper and negative peak clipper. Yes, at the end of this video, you will be able to draw different types of diode clipper circuits in order to get a desired output waveform, and similarly you will be able to draw the output waveform if you are given a particular clipper circuit. Okay, let's get started. Before going to the diode clipper circuits, the basic thing you need to know is the basics of PN junction diode. Yes. For example, consider an ideal diode. For an ideal diode, the resistance is 0 in case of forward bias, whereas the resistance is infinite in reverse bias. Okay, what is forward bias and reverse bias? You know that, suppose if you consider a diode like this, if I connect a battery in this fashion, that is positive of the battery is connected to the P and negative of the battery is connected to the N of the diode. This is said to be as forward bias, and in this forward bias the diode's resistance is 0 and then the diode will be on in this mode, and hence the voltage across the diode will be equals to 0 if it is an ideal diode. Similarly, the reverse bias is like this. Suppose if the battery is negative is connected to the P of the diode and positive of the battery is connected to N of the diode, then the diode will be in off and voltage across the diode will be equals to VI, that is, whereas VI is the voltage of the battery because it is open circuited. Okay, if you draw the waveform of the diode, it will be like this. In positive, at up to cut-in voltage it is 0, and after cut-in voltage there will be like this, and in the negative it is like this. This is the voltage and this is the current in the diode. This is the forward current and this is the reverse current. Okay, this is the forward voltage applied and this is the reverse voltage applied. If you apply a voltage in the positive direction after a particular point, that is cut-in voltage, the diode starts conducting and its current goes like this because the resistance is very negligible in the diode. If you consider an ideal diode, it will be in this way. That is, the diode starts conducting at the 0 voltage in the positive side. In the beginning only it starts conducting. It's like the cut-in voltage will be 0 in this case. Okay, so these are the basics you need to remember while solving the diode clipper circuits, and all you need to remember is if the P side of the diode has a positive voltage, the diode is on. If the P side of the diode is having a negative voltage, then the diode is off. It means it can be explained in this way, that is, the P side voltage, if it is more than the N side voltage, then the diode is on, irrespective if it is positive or negative, whatever it is being applied at this point. If the P side voltage is more than the N side voltage, then the diode is on. In the further cases, if you proceed drawing the clipper circuits, you will come across a point where another voltage source will be connected here. If the voltage you shouldn't be confused with the voltage value or voltage polarities. It's the simple thing is, if this voltage is more than this voltage, it's the diode is on. If this voltage is less than this voltage, diode is off. Simple. Okay. Depending upon where the clipper element is placed in the circuit, the clipper circuits are classified into two types, that is series and shunt. Okay. I'll explain it while go to the circuit in detail. And also another thing is positive clipper and negative clipper. That is, depending upon which part of the waveform is being clipped, the clippers are divided into these two. Basically, these are the types, that is positive clipper and negative clipper, and again depending upon how much part of the positive wave is clipped, Again, the clipper circuits are further classified, which we'll be learning in the further video. Okay, I'm starting with this basic circuit. Observe this. This circuit is having a diode and a resistor, and the diode is placed in series with the voltage source. Okay, this is here I am applying the input voltage VI at these terminals, and here I am collecting the output V0. Okay, this is the resistance R and this is the diode D. The diode is connected in the series fashion in the circuit, so this is called as series clipper. Okay, series. The simple thing is we have to write the voltage. We need to find out what the voltage is. Like suppose take two cases. When will be this diode will what decides whether if this diode is on or off is the voltage across it. The voltage across this is at this terminal it is VI, and at this terminal it is V0, right? So if VI is more than V0, what happens? If VI is more than V0, this diode will be on. Okay, if the diode is on, what is this? This diode, this circuit will be completed like this. Okay, the circuit will be completed like this, and this V0 will be following VI, because then the circuit will be like this. Because this diode is closed here, here I am applying V0, and here I am applying VI, and here I am taking V0. So this V0 will be following VI. So V0 will be equals to VI. Okay, and if VI is less than V0, what happens? This circuit will be open circuited like this, right? So the V0 will be 0 because it is not connected to the source in any way. So V0 will be equals to 0 because diode is off in this condition. Okay, so now these values we are going to put it in a graph manner. Okay, here you can observe that there is no voltage source connected in this branch. Now this means VI is more than 0. So this can be taken as this VI is more than 0 and this is VI less than 0. So for positive VI, the diode is on and it is following V0 is following VI. That is for positive VI. So it is like this. And for negative VI, the diode is off and V0 is 0, so it will be like this. So this is the diode clipper circuit, which is with V0 versus VI. Now if you draw the waveform of V0 versus T, it will be like this. Suppose consider the VI. We are applying the sinusoidal waveform. This is the VI. Okay, now what happens to the V0? For the positive VI, V0 equals to VI. So the voltage output waveform follows VI. And for negative VI, the output voltage is 0. So this is the output waveform. So you can observe that the entire negative waveform is clipped in this circuit. So this is called a negative clipper. Okay, so here you have connected the diode in the series fashion, so it is called a series clipper, and also the negative peak is clipped, so it is called a negative peak clipper. So it is it is called a series negative peak clipper. Okay. Okay, now consider another circuit. Observe that in the previous circuit the diode is connected in the series fashion, that is in series with the voltage source, right? Now in this waveform, the diode is placed in shunt manner, that is it is connected parallelly to the voltage source. So you can call it as shunt clipper. Okay, and if you write the voltage equation similar to the last model. Okay, now see that this is connected to the ground, that is negative, and this side terminal is connected to VI, right? So if this VI is more than 0, what happens? This diode will be off, right? Similarly, if this VI is less than 0, that is this side voltage is more than this side voltage, then the diode will be in on condition. So what if the diode is off, that is this branch is opened, then V0 will be equal to VI, right? And if this diode is on, this entire circuit will be closed like this, then this V0 will be equals to 0. Simple, right? Now what will be the waveform looks like? For positive Vi, that is, this is positive, this is Vi, this is V naught, this is negative Vi. For positive Vi, what happens? V naught equals to Vi. It increases linearly with Vi. And for negative Vi, that is this negative Vi, no matter how much Vi increases, V naught will be 0. Okay, 0. And if I take the input waveform like this, what happens when the Vi is more than 0, the V naught equals to Vi. If Vi is less than 0, V naught equals to 0. So this is it. Now observe that in the previous case and this case, both cases the waveform is same, but the difference is the manner in which you have connected the diodes in the circuit. That is, here you have connected it in a shunt manner, and here you have connected it in the series manner. Okay, but the output is same. Here this is called a negative clipper, again negative peak clipper. Okay, and it is a shunt one, so this is called a shunt negative peak clipper, and this one is called a series negative peak clipper. Okay, now I think now you can understand that if I want a positive peak clipper, that is, if I want to clip the positive peak and if I want the negative one, all you need to do is reverse this diode polarity, that is, connect this diode in the reverse way. Similarly, here also you have got that is, here you have got a negative clipping by connecting the diode in this manner. What if you reverse the diode? Then you will be getting a positive peak clipper. Let's do it. Okay, I want a positive peak clipper both with series and shunt. That is what we are going to do now. So in the previous case, from the circuit I have drawn the waveform, but now to get a desired waveform, I am drawing the circuit by guessing. See, now this with the same circuit, I'm just reversing the diode polarity like this. I'm reversing the diode, and the remaining circuits is same. This is V naught and this is Vi. Okay, diode ideal one, and this is the resistance. Okay, now again the diode is connected in the series fashion, so this is a series clipper. Okay, now Vi, when Vi is more than 0, what happens? This diode is off, right? Now if this diode is off completely, this is disconnected with the source, so then the V naught will be equals to 0. V naught will be equals to 0. Suppose if Vi is less than 0, that is, Vi, this side voltage is less and this side voltage is more, then what happens? The diode starts conducting and the diode will be on, and what happens? This is closed and this V naught will be equal to this Vi, because this will be short circuited when the diode is on. Okay, now what is the waveform? For positive Vi, that is when Vi is more than 0, V naught equals to 0, right? For negative Vi, V naught equals to Vi, that is, it is like this. Observe, see, this is exactly reverse to the previous case. Similarly, if I am taking the Vi as this, then what happens? For positive Vi, V naught equals to 0, that is 0. For negative Vi, V naught follows Vi in this way. See, exactly opposite to the previous thing. Here the positive peak is clipped totally. Here the negative peak is clipped completely. Okay. So here this is called a positive peak clipper. Okay, and since the diode is connected in the series manner, this is called a series positive peak clipper. Okay, and again I'm redrawing this circuit, just reversing the diode polarities. In this case, what happens? In this way, this is V naught, this is Vi, R, and ideal diode. Okay, now this is called a shunt clipper because the diode is connected in a shunt manner. Okay, now this is 0, it is connected to the ground, and this voltage, if this Vi is more than 0, what happens? The diode will be in on condition, then this will be short circuited, then V naught equals to 0. Similarly, Vi, if Vi is less than 0, what will be there? This is a negative and this is positive. The diode will be in off condition and this is completely open, right? Now V naught equals to Vi. Okay. Now if I draw the circuit, this is Vi, this is V naught, right? Now for positive Vi, V naught equals to 0, and for negative Vi naught equals to Vi. This is Vi, this is V naught, right? V naught equals to Vi, a positive. V naught follows Vi. Similarly, this is the input. For positive Vi, this is the Vi, right? When Vi is positive, V naught equals to 0. This is V naught. And when Vi is negative, V naught equals to Vi. That is V naught follows Vi. So this is the positive P clipper with a shunt diode. That is this is the series positive P clipper and this is shunt positive P clipper. You can observe from these 4 cases, that is just the diode fashion is reversed in these two and the output waveform is reversed. Similarly, in these two also the diode is connected in a reverse manner and the waveform is reversed. So with the same kind of waveform can be obtained from both series and shunt, and that is another point you have to note down. Okay, now this is the basic types of series and shunt clippers, and the next level is when you get a voltage source which is connected in this along with the diode. Okay,